Ever written code that needs to make decisions about its own output quality before moving forward? You'll see how to build a joke generator that automatically evaluates its own work, routes jokes through improvement steps when needed, and only delivers the final punchline when it passes quality checks. The pattern uses conditional edges to create a dynamic workflow where each joke gets exactly the processing it needs. No more, no less. From typing extensions, import TypedDict. From LangGraph, graph import state graph start end. From IPython, display import image display. Hash graph state. Class state TypedDict. Topic SDR. Joke SDR. Improve joke SDR. Final joke SDR. Hash nodes. Def generate joke state. First LLM call to generate initial joke. MSG equals LLM. Invoke. Write a short joke about state topic. Return joke. MSG content. Def check punchline state. Gate function to check if the joke has a punchline. Hash simple check. Does the joke contain? Or if I instate joke or I instate joke. Return pass. Return fail. Def improve joke state. Second LLM call to improve the joke. MSG equals LLM. Invoke. Make this joke funnier by adding wordplay. State joke. Return improved joke. MSG content. Def polish joke state. A third LLM call for final polish. MSG equals LLM. Invoke. Add a surprising twist to this joke. State improved joke. Return final joke. MSG content. Hash build workflow. Workflow equals state graph state. Hash add nodes. Workflow add node. Generate joke. Workflow add node. Improve joke. Workflow add node. Polish joke. Hash add edges to connect nodes. Workflow add edge start. Generate joke. Workflow add conditional edges. Generate joke, check punchline fail. Improve joke, pass, end. Workflow add edge, improve joke, polish joke. Workflow add edge, polish joke, end. Hash compile. Chain equals workflow compile. Hash show workflow. Display image chain get graph. Draw mermaid PNG. Hash invoke. State equals chain, invoke, topic, cats. Print, initial joke. Print state joke. Print, \n. If improved joke and state. Print, improved joke. Print, state improved joke. Print, \n. Print, final joke. Print, state final joke. Elsie. Print, final joke. Print state joke. This demonstrates a conditional workflow pattern using LangGraph state machine architecture. The code implements a multi-stage joke generation pipeline where each stage conditionally routes to subsequent processing based on content evaluation. What makes this distinctive is the declarative graph structure that separates the workflow definition from the node implementations, allowing complex logic flows without nested conditionals. The pattern works by modeling the process as a directed graph, where nodes represent discrete operations and edges define transition rules. Conditional edges use simple evaluation functions to determine routing, creating a dynamic path through the workflow. This separation of concerns means you can modify individual nodes or routing logic independently, and the state object maintains all intermediate results automatically. This approach matters because it transforms complex, branching logic into a maintainable visual structure. It's particularly valuable for iterative processes like content generation, where quality checks and refinement steps are needed. The graph visualization makes debugging intuitive, while the state management eliminates manual variable passing between steps. Compared to linear scripts or nested if-else chains, this pattern scales better for multi-stage processes with conditional branching. Let's break it down. From typing extensions, import TypedDict. From LangGraph, graph import state graph start end. Imports TypedDict for type-safe state management and StateGraph for building workflows. The start and end constants define entry and exit points in the graph, enabling clear workflow boundaries. Def generate joke state. First LLM call to generate initial joke. MSG equals LLM. Invoke. Write a short joke about state topic. Return joke. MSG content. This is the first node function in our joke generation workflow. It takes the initial topic from the graph state, invokes the LLM to generate a joke, and returns it with the key joke to update the workflow state. The pattern establishes how each node receives the current state, performs an operation, and returns state updates. Def check punchline state. Gate function to check if the joke has a punchline. Hash simple check, does the joke contain? Or if I instate joke, or I instate joke. Return pass. Return fail. This is a conditional gate function that determines workflow routing. It performs a simple punchline check by looking for question marks or exclamation points in the joke text, returning pass to end the workflow or fail to trigger joke improvement. This pattern enables conditional branching in state-based workflows. Def improve joke state. Second LLM call to improve the joke. MSG equals LLM. Invoke. Make this joke funnier by adding wordplay. State joke. Return improved joke. MSG content. This node handles joke enhancement by making a second LLM call. It injects wordplay into the initial joke, creating a more sophisticated version that gets stored in improved joke. This is the conditional improvement path when the first joke fails the punchline check. Def polish joke state. A third LLM call for final polish. MSG equals LLM. Invoke. Add a surprising twist to this joke. State improved joke. Return final joke. MSG content. Final polishing step in the joke generation pipeline. Takes the improved joke and adds a surprising twist via another LLM call, storing the result in final joke. This ensures the output meets quality standards before completion. Hash build workflow. Workflow equals state graph state. Instantiates the workflow graph using our state TypedDict as the state schema. This defines the data structure that will flow between nodes, ensuring type safety and consistent state management throughout the joke generation pipeline. Workflow add node. Generate joke. Workflow add node. Improve joke. Registers the 3 core processing nodes in the workflow graph. Each node represents a distinct step in the joke generation pipeline, with generate joke creating the initial content and improve joke handling the refinement phase when needed. This modular design enables conditional branching between nodes based on quality checks. Hash add edges to connect nodes. Workflow add edge start. Generate joke. This establishes the workflow's entry point by connecting the start node to the generate joke node. It ensures every execution begins with joke generation, creating a clear linear starting path for the graph. Workflow add conditional edges. Generate joke, check punchline, fail. Improve joke, pass, end. This creates a conditional branch in the workflow. After generate joke executes, It routes to either improve joke or end based on the check punchline function's return value, implementing quality control before proceeding. The mapping dictionary defines the routing logic. Fail triggers improvement. Pass terminates the flow. Workflow, add edge, improve joke, polish joke. Workflow, add edge, polish joke, end. Defines the linear workflow for joke refinement. After improving the joke in the improve joke node, it automatically routes to polish joke for the final twist. The final edge to end terminates the workflow, ensuring no unnecessary processing after the joke is complete. Hash compile. Chain equals workflow compile. This compiles the graph into an executable workflow. The compilation step validates all nodes and edges, ensuring the workflow is properly structured before execution. Without this, the graph would remain an unexecutable blueprint. Hash show workflow. Display image chain get graph. Draw mermaid PNG. This visualizes the workflow graph using mermaid.js. The draw mermaid PNG method generates a diagram showing node connections, making it easy to verify the conditional paths and execution flow before running the chain. Hash invoke. State equals chain, invoke, topic, cats. This executes the compiled workflow with the initial input topic. The invoke method triggers the state machine, starting at the generate joke node and following the defined edges based on conditional checks. This is the entry point that transforms the static graph definition into an active joke generation pipeline. Print initial joke. Print state joke. Outputs the initial joke generated by the LLM. This serves as the baseline result before any improvements, letting us compare the original with later versions in the workflow. If improved joke in state. Print improved joke. This conditional handles the workflow's branching logic where jokes with punchline skip improvement. Unlike the JS version that logs a failure message when improved joke is missing, this Python implementation treats the absence as a success case. It silently outputs the original joke as final via the else branch when the joke passed quality control and didn't need improvement. The in check safely handles both paths while maintaining the workflow's pass-through behavior for valid jokes. Print final joke. Print state final joke. This code prints the workflow's final output with two paths. If the joke fails the punchline check punchline, it shows the improved joke and final polished joke. Otherwise, it treats the original joke as the final output, no improvements needed. Unlike the JS docs example, it doesn't explicitly flag failures. It simply returns the original joke when it meets quality criteria. LC. Print final joke. Print state joke. This else block triggers when the joke fails the punchline check, no, or meaning it never entered the improvement pipeline. It falls back to printing the original joke as the final result since the conditional edge routed to end without generating improved joke, or final joke, matching the fast exit behavior in the docs where unacceptable jokes terminate early. LangGraph state-driven workflow pattern. This implementation demonstrates how StateGraph orchestrates multi-step LLM workflows using explicit state management and conditional routing, with TypedDict enforcing type safety across nodes. The check punchline gate function uses simplistic punctuation checks that may produce false positives, so consider semantic analysis for production use. StateGraph's visual debugging via image rendering makes complex workflows immediately inspectable, reducing iteration time during development.
The node that never executes completes the workflow.